This video goes over completing the square. Basically, we have these things called perfect square trinomials that mean when you factor them, they factor kind of neat. So here's an example of one. And so when we factor this, we're looking for the two numbers that multiply together to give us 9 and add together to give us 6. So 3 and 3. And so it factors as x plus 3 squared. And so that kind of creates an advantage for us, and so we want to be able to make perfect square trinomials. Well, it turns out that's really easy. You need to remember three things. Half it, square it, add it. So we're going to take, on example 2, we're going to take half of 12, which is 6, and square that, which is 36, and we're going to add it on to the end. And now we're also going to factor that. So we want two numbers that multiply together to give us 36 and add together to give us 12. So 6 and 6. When you half it, square it, add it, you're designing that equation to factor where the factors are going to be the same every single time. So we're going to write it from now on, we're going to write it as x plus 6 squared. So let's look at the second one. We half 18, we get 9. We square it, we get 81. And then when we factor it, it should look like this. So the two numbers that multiply to give us 81 and add together to give us 18 are 9 and 9. So x plus 9 squared. Okay, so that is how you make a perfect square trinomial. Now we're going to use that. I'm just going to do probably just one example with you, and then you can do the rest. If you look, the examples up here are worked out for your viewing pleasure. So this one right here is completely worked out, and it gives you the steps to the left. Okay, so on example 3a, first thing we want to do is we want to look at this x term, and we see that if we half that, we get 1, and 1 squared is 1, not negative 5. So we need to get that negative 5 out of the way. So I'm going to add it to both sides. It cancels out over here. Now on this next step, I'm going to leave enough room for the thing that I'm adding. So I leave a little blank. I'm going to go ahead and do 0 plus 5 is 5, and I'm also going to leave a little blank over here, because what you do to one side of the equation, you have to do to the other. So I half 2, I get 1. 1 squared is 1. I'm going to put that on both sides. Now the whole reason that I do that is so that I can factor this as something squared, as we just talked about. So I'm looking for the two numbers that multiply together to give us 1 and add together to give us 2. So that's going to be 1 and 1. Okay, so now I'm trying to solve for x, so what do I need to do next? Well, I'm going to square each side. Square root each side, sorry. Remember, when you use square roots to solve, you have to put the plus or minus. I cannot simplify square root of 6, and so now I'm just trying to get x by itself. So what do I need to do to get x by itself? I'm going to subtract 1 from both sides. Since it's the root 6 and not just 6, I can't actually subtract 1, so I'm going to keep it separate and write it like this, and that would be our final answer. I am going to do this second one with you just to show you a different outcome that you could get. So let's move the 28 out of the way. So x squared minus 16x plus blank equals negative 28 plus blank. It is still adding even though it's negative 16, so just in case you were wondering. So half of 16 is 8, squared is 64. I'm going to add that to both sides. I'm going to factor this left side. This right side equals 36. So I have x. Two numbers that multiply together to give us 64 and add together to give us negative 16 is negative 8 and negative 8. So it's going to look like this. So now why did I do that? Well, because it makes it easy to solve. I just have to square root. So I have x minus 8 equals plus or minus. Square root of 36 is 6. I'm going to add 8 to both sides to get x by itself. And so I have 8 plus or minus 6. 8 plus 6 is 14. And 8 minus 6 is 2. So those are my two solutions.